Hello, today we are going to take our knowledge of molar mass from the last unit and do a new kind of conversion, going from grams to moles and moles to grams. All right, so our first problem here, we have an example and then I have steps to help you map out how to solve a problem. If you're struggling with figuring out what goes where in your conversion, do not skip these steps, okay? It feels tedious probably to write all of it out, but it can help you organize your thoughts, okay? So the problem that we have here is that we have silver metal, and it's used in the manufacture of lots of different things. If you're designing a piece of jewelry that requires 0.750 moles of silver, how many grams of silver would you need? All right, so we are given moles of silver, right? That's the units that we know, and we're trying to find the grams of silver. So our plan is going to be to go from moles to grams. All right, so this is a relatively straightforward plan because it's just one step. All right, and then to do that, we're going to need the molar mass. So if you take a look at your periodic table, we have silver here is number 47. All right, the number below it is 107.868. Okay, so that is going to be the conversion factor that we're going to use. So now let's set up the problem. Okay, if we have 0.750 moles of silver, that's always going to go in front, the number that they give us in the problem. And then our conversion factor could either be 107 on the top or 107 on the bottom. All right, 107 goes with the number of grams in the mole. All right, and grams is what we're trying to find, so that will go on the top in this case. Also, we're starting with moles of silver, so we want moles of silver to cancel out. So the moles, or 1 mole, should go on the bottom. All right, and then if we do 0.75 times the 107.868, we get 80.9 grams of silver. All right, here's another example. This time we have a compound, NaCl. All right, we are given the number of grams of NaCl, and we're trying to find the number of moles of NaCl. Okay, our plan, again, it's just going to be one step. We're going from grams to moles, and we'll need the molar mass. So just as a reminder, we look up the mass of sodium, which is Na, the mass of chloride, which is Cl, add them together, and that's the molar mass of the compound. That's how many grams are in 1 mole of NaCl. And then this time when we set it up, again, grams in the front because that's the number given in our problem. Since we're trying to find moles this time, the 1 mole goes on the top, and the number of grams that's in a mole, or the molar mass, goes on the bottom. All right, since that number is on the bottom, it would be 737 times 1, and then divided by the 58.443. Okay, I know this is set up here and I have the answer here, but I encourage you to put it in your calculator and make sure that you're doing the math properly after it's set up. Okay, that gives us 12.6 moles. All right, so now we have done a few different kinds of conversions, right? We have gone from moles to particles, like atoms. We've gone from moles of element to moles of a compound, or number of atoms to number of molecules using the subscripts in our formula. And then, back and forth between moles and molecules. So the conversion factors we've used prior to this lesson are Avogadro's number, and then also the subscripts in our molecular formula. And now in this lesson, we just added molar mass, all right? This table is in your notes, and it can be helpful to make your plan if you're not sure how to proceed with a problem. So let's do one example where we combine the skills we've learned. Okay, so if we have a 10-pound bag of sugar, all right, it's 4,536 grams. This is the formula for sucrose, which is sugar. Okay, and we want to find out how many molecules of sucrose are present. All right, so get used to knowing that the name and the formula are 2 different ways to say the same thing. All right, these are the same. Okay, I can call it sucrose, but because I gave you the formula, you also know that that means 12 carbons, 22 hydrogens, and 11 oxygens. Okay, so now what we were given in this problem is grams of sucrose, and we're trying to find molecules of sucrose. Okay, so if we look back at the table, we can go from grams to moles and we can go from moles to molecules, but we can't go straight from grams to molecules. We don't have a conversion factor for that. So our plan here is going to be to go from grams to moles first and then from moles to molecules. All right, and you'll find that as we build on these conversions, frequently the first thing we do is get to moles, and then from moles we can go to a lot of different things. So this is a common kind of plan that you would come up with. All right, the molar mass of sucrose, which is C12H22O11, is 342.297 grams. I just did the mass of carbon times 12, plus the mass of hydrogen times 22, plus the mass of oxygen times 11. Okay, and then to set up this problem, we take the number given in our problem, 4,536 grams, right? Since we're starting with grams, grams will go in the bottom of our conversion and 1 mole in the top. Remember, in our first step, we're going from grams to moles, so that's what this conversion factor will do for us. All right, and then our second step is to go from moles to molecules. So now we want the mole and the mole to cancel. All right, and then the number of molecules is Avogadro's number. Okay, that will go on the top. And then we'll do this times the 6.02 times 10 to the 23rd. The 342.297 is just times 1, so it'll be this times this divided by this. All right, again, practice putting that on your calculator and make sure you get the same number that I do, because this is where we're going to use that EE button. And then you get an answer of 7.980 times 10 to the 24th molecules. All right, it's always a good idea to make sure this number makes sense. If we're talking about atoms or molecules, a big number makes sense. All right, if we're talking about grams or number of moles, you probably don't want something times 10 to the 24th. That's a whole lot of grams and wouldn't make sense. All right, but in this case, it's molecules, so that number makes sense. All right, and so that wraps up our gram to mole conversions and then also adding in molecules.